technology lab. And so historically, I've done a lot of work on input and interaction techniques. That's sort of where I'm coming to this area. So we've done a lot of work on smartphones, but then more recently focusing a lot on wearable devices, such as smartwatches and smart glasses. So the kind of thing we've been thinking about for a long time are some of the issues that get cropped up earlier in the talks. So this is issues like mobility. So for example, this is a text entry system we developed 4 or 5 years ago now, which is explicitly designed to support an HMD wearer during mobile text entry. So when they're walking along, they're going to be entering text. So here you can see we have a system on the fingernails, and as you touch the different fingers, we can extract some qualities like input to support with sufficient richness to support text entry. And so what's great about this is it doesn't really disrupt you while you're walking. So you can actually enter text at a reasonable speed with reasonable accuracy when you're fully engaged. And so you can imagine trying to do this with a poke and hunt text entry system would be basically impossible. So we also do lots of other work a bit more recently. This is something we've been doing now. This is on a watch. This is using a sonar signal from the smartwatch to extract and reconstruct the hand pose. So this is the kind of work that we are generally doing. So obviously some of this does involve AI. So if you can see this model here, you can imagine what it looks like already. It looks something like this. And so this will be AI. I would say this is not AI in any particularly interesting sense, although the actual model is relatively sophisticated and certainly takes a long time to train. So really what I want to talk about more is a lot of what we've already heard today, which is what my students are beginning to think about when we think about these types of smart glasses. And so basically what I would characterize they're doing is they're starting to think about smart glasses as the eyes of generative AI. And so this means that what they're trying to do is they're trying to move from a model where we interact with AI through textual prompts, which is largely dominant today, or even we might say that we speak to it, which we also do often, to one where actually AI is largely driven by what we see, which is again a theme that's been recurrent through this presentation. So this seems important for a number of reasons. One is that, as again, we're a lab that's been focusing on wearable devices. So one reason is it seems very integral to the actual value proposition of those wearable devices. So we already have a lot of devices that we carry with us. For example, we have a smartphone, and that, you could say it does a lot of different things, but let's just say it arguably meets a lot of our communication needs. Yeah. And we also, many of us wear smartwatches. We do, in fact, already wear smartwatches. But for that device category to be valuable, basically, it doesn't replace our smartphone. Nobody is ditching their smartphone to wear a smartwatch. And I think no matter what functionality was in that smartwatch, that's not going to happen. The reason that we wear smartwatches is because they add new functionality that, in fact, the smartphone does not. Okay, so in this case, the smartwatch is predominantly its use case is health tracking. And if it didn't have those health tracking functions, maybe many people would not purchase those devices. And so when we come to smart glasses, we actually need to try to say, well, we can't expect that the smart glass is going to replace the communication device or information assistant on our phone, or even, to be honest, the health tracker on our watch. Actually, we're going to have to look for new types of applications that this can enable that we fundamentally cannot achieve with these existing devices. We're not going to stop using our phones just because we've got glasses. They're going to have to do something new for us. And so obviously what we are thinking, or my students are thinking, is that Gen AI, generative AI, may be one of those enabling applications, maybe kind of what sets smart glasses apart from these prior form factors that's sort of enabling making the technique viable. So we can see some of that already. So some nice videos, which I actually have also selected, but I actually took Meta's videos, where we start to see some of this coming. So these are on the Ray-Bans from Meta. So they have these very straightforward scenarios where you begin to get some of the same functionality.
Hey Meta, remember my room number?
Sure, I'll save a reminder.
Hey Meta, what's my room number again?
Your room number is 350.
I have no idea why she wants to know a room number. Apparently it's critical.
Hey Meta, look at this building and tell me about it.
This appears to be a courthouse or government building.
Also seems like rather pointless information. It says this appears to be a courthouse. But nonetheless, we start to see some of this where, I don't know if you know these Ray-Bans, they're actually one of the more successful smart glasses. It's basically a voice assistant with an added camera. So predominantly it's used to post social media messages, but they also have this early stage kind of AI functionality where it's again doing some of those things where it takes an image and then responds to a voice command to process that image in some way. And so these examples I don't think are the most compelling, but we do see some elements that are interesting in those. But I find that more and more sort of commercial applications of these smart glasses are trying to touch on this. So I work with a company loosely called SoftEye. They're a camera manufacturing company. So they build themselves exactly this, as kind of the eyes of Gen AI. So their goal, their startup, is to produce hardware that can provide, in a very discrete pair of smart glasses, provide hardware that can provide high quality images for sustained periods. So something like the Ray-Ban Metas is light format, that can actually provide a lot of video content that can feed into Gen AI to provide various types of support. So they isolate things like context-aware computing, memory and recall, and scene recognition and processing type applications. So there's kind of a lot of interesting potential there. We've heard a lot of those things today. I want to discuss some of the ones that that have come up in our discussions and in my discussions with other people, just to sort of flesh out the kind of things that we think might be enabled by these types of scenarios. So one that's come up repeatedly in various contexts is health-related applications that go beyond the kind of health support that we currently get in a wearable. So for example, one is in particular is in blood sugar monitoring. So in this particular application, the notion is that you can wear, or somebody who's sensitive about their insulin levels, their blood sugar levels, I should say, is going to wear a continuous blood sugar monitor. So if you're not familiar with these devices, you basically use a permanent needle or semi-permanent needle, you put it in your arm, usually lasts about 2 weeks and provides a continuous tracking of your glucose levels. So every 5 to 15 minutes typically. So this is providing this very long sustained medical reading, but nonetheless it remains extremely hard to interpret. So this is kind of something that's going to fluctuate. You're going to have to continuously monitor it over time. You're going to have to correlate it with your eating activity, your exercise activity, your stress levels, even your health, as your blood sugar can vary from very many factors. And so it's extremely challenging. You get a lot of information, but it remains extremely challenging to actually process that information. And so what we found, very simply, is that it's actually quite easy to create an LLM-based system that can add a lot more insight to this. For example, in a food intake tracker. So if you have an egocentric video, this can actually scan not just what your meal looks like at the start, but can actually scan every aspect of how you consume your meal. So the order in which you consume the food, the rate at which you consume the food. So it can give you an awful lot of your food over time. It can catch every snack you took, and so forth. And so we get a lot more detail than we get from conventional sensing about food intake, meal composition, and eating habits. And actually, not only can we get all that information, but we can also theoretically feed that back in to try to make sure that the impact of those practices on the blood sugar levels can be more, there's nothing precise about health, but can be more meaningfully understood. So this is a potentially kind of a novel health tracking scenario that could be extremely impactful. So these blood glucose meters can be extremely expensive. So if you're wearing one of these, you're already significantly investing in your health. And so actually having a pair of smart glasses that can make more value out of it seems like a pretty meaningful extra. Another scenario we have is in a learning space. So one that discusses a kind of a smart tutor or assistant. So this would take, say, a student who's engaged in a kind of heterogeneous learning session. So in this session, they might be looking at some sort of print material that their faculty has prepared, or looking at some material on the internet, a textbook. They're likely also using some mixed media, such as looking at YouTube videos. They may be looking at arbitrary random sources on the internet, such as Wikipedia, to flesh out their knowledge. And to be honest, every student I know is also asking LLMs for what to do. Okay? So we get this learning session that the student is engaged in that is extremely hard to track and trace. But again, with an egocentric view, we can in theory track the students' activities across that whole spectrum of different activities. So they do 2-3 hour study session. And we can start to accumulate that into customized learning plans or learning reflections for them. So for example, we could summarize the topics that they actually studied rather than the topics that are prescribed. We could understand and provide assessments. So depending on what they actually studied, we could generate custom quizzes for what they did. You can also imagine that LLM can isolate challenges, so areas that they repeatedly return to, areas that they skipped over. We can imagine that the LLM could start to reason about what kind of material they need to do more on. And also then highlight omissions. So if in an independent study practice like this, it's not unlikely that a student's coverage of the topic will be disequal, will be problematic. And so an LLM could actually provide some guidance as to more appropriate directions they could move in. And then, finally, that shouldn't be there yet. Let me just jump through. A final scenario, which is kind of the classic scenario. If any of you're all probably familiar with the Mitzvah project from MIT, is kind of driving this old wearable computer vision from the very past. Suggests that glasses aware, smart glass, could be a memory aid. It could remind me when I meet somebody who they are. It could track objects in my environment and tell me where I last saw them. It could support me in to-do lists by remembering what I have to do, or even detect the kind of tasks I'm doing and intervene to make sure that I complete all steps correctly. We've seen examples of these in the other talks today, so these kind of classic applications. So these are all the types of applications that I think the eyes of Gen AI could start to provide for us. However, there are many challenges or issues, which is kind of what I want to spend the last few moments on discussing. So some are technical, and indeed the company I work with is mainly focused on those technical challenges. So one of these fundamental challenges is how do you create a camera system that is going to be able to track people's activity for a sustained period, provide that kind of power. And so we can build it as a prototype by really compromising on the comfort and practicality of that device. But if you're going to build it realistically, it still remains a huge challenge. And it's not just a hardware challenge, because I think we actually have to find ways functionally that it will be practical by trying to find the minimum information needed to achieve this objective. So there are a number of strategies. You can certainly record all the video, which is kind of what we do in the research community. We're just going to hit record for that experimental session, and then we're going to get all the video, we're going to analyze it in full. But this is not really a practical scenario in many ways due to power consumption and others. We also see in devices like Metas or some of the other applications we saw, you respond to explicit prompting by the user. So the user initiates a query, you take a picture, and you're done. And that obviously minimizes battery life. But that supposes a very narrow view of the generative AI. It's only ever going to respond to your request. And so actually its kind of scope is quite narrow. Another way that I think we're going to see increasingly common is you're going to try to sense properties from the behavioral properties of the people. So we saw this already. People are talking about using eye gaze to disambiguate queries. It's obviously a good way to go. We might also see brain signal processing, EOG processing, many other types of processing that could be able to do kind of cue critical moments for appropriate sampling. Another approach would be very low power scene sampling. So for example, have multiple cameras, including cameras that can take extremely low power images very regularly before you trigger activation of a high cost image. Okay, I didn't realize I'm almost out of time already. However, what I wanted to sort of say about this vision of AI, of Gen AI, is that it still remains quite traditional. So we have this vision of what I want to say about the smart glass LLI is it's quite different than what we have a current, the dominant view of a large language model use. So I would say that most current large language use is reactive. And what I mean is that we tend to conceptualize, we've again heard this in the presentations in this session already, we tend to conceptualize the model as an intern, a coworker, teacher, a coach, but something we query and discuss with. So we are in charge and we are going to this for sometimes information or performance of a job or advice, but we are basically, we are pushing it, we are in the charge. But if we go to this camera-based system, ultimately we're already supposing a system that has much more proactive intervention. In which case, the kind of metaphors we might think are as a co-pilot that's intervening, or a butler or a sixth sense where it's going to come in and take much more intervention. And so when I thought about this, or when we are thinking about this, then we look back at the past and we can make some critical reflections on this. So we've seen this type of technology before. Not terribly successfully, yeah. But this technology here is quite interesting. So this was built on Bayesian networks, among other technologies, and I should say in the storied version on Bayesian networks and other types of user predictive technology. So it observes users, models the probability of what they want to do, then interjects responses that require explicit attention. And this was disliked. It was unpopular, it was annoying, it was irritating, it kept bothering the users, it was not. But we have seen these algorithms be incredibly successful in other domains. So for example, such similar prediction networks are used to drive feed recommendation systems. So Netflix is explicit about this, they publish research on it. But it's largely likely that many similar feed recommendation algorithms are using the same types of user prediction technology. So these are also agents. These are just agents that are fully proactive, and so that we never actually see them at all. And so these agents, obviously, we can all watch the movies we want, but in the, say, the Facebook context, so forth, there's been a lot of unprecedented consequences of such agents when we decide that we're not actually keen on these agents when we have to do anything, when we actually are in discussion with them. But actually we can accept those agents in situations, or we can all use those agents in situations where they are entirely in charge, they're just feeding us the data. And then there are many negative consequences to this. So for example, filter bubbles and other. So I see that we are moving towards this position of maybe a proactive set of agents, but then we also need to really start to consider very early the negative consequences of that, based on prior examples that have suggested that they can be quite extreme. Yeah, so there are many issues I see with this, but I think that some of them have come up already. So surveillance, agency, consent, all came up briefly in our discussions already. I also feel like surveillance and consent are, we talked about it in privacy, but I think surveillance and consent's slightly better terms perhaps. But I also feel that these are just dropping from the public awareness. As when Google Glass came out, these were killer issues. But now somehow our society has changed to be much more comfortable, have a much lower threshold for violation of these issues. Nonetheless, they need to consider them. So I just want to close by saying I think that agency remains the critical issue. So how can we design interfaces that might be proactive, that might use the power of what we can sense from the smart glass system, but still allow users to remain in control, so we avoid the unintended consequences of prior examples of such sort of agentic systems, such proactive systems, which what we've seen in the past have sort of morphed into systems where we can no longer see them, they fade into the background, and then the implications of those proactive choices in these feed recommender systems have been, should we say, profound and not very positive. And so I guess I end with a warning that this seems to be what we should be thinking about seriously. So thank you.
Thank you for the talk, and I wanted to ask both of you a question. We can talk on the hallway. One of the things that always boggles my mind is that maybe not the wrong terminology. I mean, you cannot extend reality. Reality is already reality. You cannot add more to it because it becomes reality. So instead, I'm thinking about if the focus should be about extending perception and make it more human-centered. Instead of just slapping things into the world, it's about what about enhancing the way we perceive the world. And from that point of view, I wonder what kind of solutions and approaches will emerge. I mean, I like the part that you start adding at the end in terms of mediation agency. And I wonder, how do you think that slight change in wording may affect the way that you do work and your perspective in the work you did?
So I think if you view augmented reality system as a system that can provide extrasensory perceptions, then perhaps the implications may be reduced in some way, but any decision that we make about what information to present or not present can have unintended consequences. And I guess the warning about agency is related to those. The designers make choices about how they feel or how they believe the implications of their choices, what the end results will be, but those are very hard to predict, and so they need to be continuously monitored and checked. But yeah, for example, in some cases, for example, extrasensory perceptions that can provide additional details around the world and so forth may be less harmful than certain other types of intervention that we could imagine. I don't know if that helps.
There's no right or wrong answer.
Sure.
I wanted to provoke a bit.
Sure.
Can you elaborate on the sixth sense, the sixth sense?
So here, I was just trying to think of ways that because I don't think we have a good, because we have 4 reactive LLMs. I think we have a kind of a good set of metaphors. So these are from Jacob Nielsen, actually. But he recently provided a breakdown, and he said that, the early LLMs we could think of as an intern. You would give them very simple tasks, and they could go off and do these tasks. But as these technologies have advanced, they can act much more as equals, or teachers, perhaps it's maybe not that difficult, but even coaches to, as we heard in some of the design ideation sessions, they can sort of provoke you to do better. Yeah. And so I think these are quite established metaphors. But then if we're thinking about proactive, then a butler would be a metaphor where there's somebody proactively determining what you want, providing it at the right moment. A sixth sense might be in that perception sense, where you might have a sixth sense for danger or whatever, spidey sense, where it would be warning you or providing you advanced knowledge that something that is not in your regular perception. Or in the diabetes monitoring scenario, a sixth sense so that you could be aware that if you eat something, the subsequent patterns, the blood sugar patterns will be in this way. So you may have an elevation of blood sugar that previously you wouldn't be aware of because you haven't associated this particular food with problematic response. So a sixth sense in that sense, that makes sense.
Well, based on the food, is that good for diabetes? To me, that's not sixth sense, that's more science.
No, but what it's providing the user with is a sixth sense. So yeah, sure, the blood glucose response is scientific, but the sixth sense is what the user gets. For example, the people cannot manage their blood sugar. It's a massive medical problem. So even though it is scientific, the medical condition is scientific, and the dietary conditions are scientific, there's a large population of people that struggle to make the right dietary choices continuously. It is extremely challenging. So a sixth sense in this sense would be something that would be providing more information about that situation so that you can make better choices ahead of time. So that's here I'm just throwing out potential metaphors. I don't not fully developed, but I feel we need to develop those metaphors to make the LLMs reasonable, to make them understandable, to design them effectively.
We are out of time, but I think you guys can take a break, and we come back at 15, which is 3